Teaching problem solving, a meta-procedural approach. Outline of topics to discuss. What is a problem? Methods for solving problems. The memorization method, the procedural method, the problem-solving method, and the problem-solving procedure method. What is a problem? According to Merriam-Webster, the definition of a problem, definition 1A, is a question raised for inquiry, consideration, or solution. B, a proposition in mathematics or physics stating something to be done. Methods for solving problems. Number 1, memorization. Commit to memory or learn by heart. The technique, repetition of an answer. Number 2, procedural. A series of steps followed in a regular definite order. The technique is repetition of the steps to an answer. Number 3, problem solving proper. The process of finding solutions to difficult or complex issues. This is without the knowledge of procedure steps. The technique, creation of a procedure for steps to an answer. Number 4, problem-solving procedure. The process of following a procedure to create a procedure to find solutions to difficult or complex issues. The technique, employ a procedure to create a procedure for steps to an answer. Memorization method. With knowledge of accepted fact, simply remember an answer. There are many techniques used for memorization, a couple of which are repetition, association, but the assumption behind memorization is that the specific answer is a known quantity. Procedural method. With knowledge of existing steps, use the information given to produce an answer. So number 1, you gather your information. Number 2, you find an existing procedure. And number 3, you perform that procedure. The assumption is the procedure is a known quantity. Procedural method. Example, 2 times 3 equals. Step number 1, gather information. What am I given? I'm given the number 2, the number 3, and a request to multiply 2 by 3. What am I to give back as an answer? Simply a number. Procedural method. 2 times 3 equals. Step number 2 is find an existing procedure. We're going to use the subtracting from groups of quantities procedure. Step number 1 is use the first number as the number of groups. 2, use the second number as the group quantity. 3, remove 1 from each group until the groups are empty. Number 4 is the answer equals the sum of quantities removed from all the groups. Procedural method, 2 times 3 equals. Number of groups equals 2. Quantity of each group equals 3. Remove 1 from each group until groups are empty. Increment number 1, we remove 1 from group 1 and 1 from group 2 for a total of 2 removed. Increment 2, we remove 2 from group 1 and 2 from group 2 for a total of 4. Increment 3, 3 are now removed from group 1 and 3 are removed from group 2 for a total of 6. The answer equals the sum of the quantities removed from the groups. 2 times 3 equals 6. Problem-solving method. By knowledge of similar procedures and facts, we're going to use information given to produce an answer. So step number 1, we're going to gather our information. Step number 2, we're going to create appropriate procedure. And number 3, we're going to perform that procedure. Now the assumption here is that there is no existing procedure for us to use, so we must create one. Problem-solving method, 6 divided by 2 equals. So step number 1, we're going to gather our information. What am I given? I'm given the number 6, I'm given the number of 2, and then I'm given a request to divide 6 by 2. Now what am I to give back as an answer? Again, I'm to give back a number. Problem-solving method, 6 divided by 2 equals. Step number 2, create a new procedure. We're going to implement a creative strategy called copy and transform. Now, this new problem, 6 divided by 2, feels like it's kind of opposite from our existing subtracting from groups of quantities procedure. So we'll create a new adding of quantities to groups procedure. Step number 1, instead of the old use the first number as the number of groups, we're going to use the first number as the total quantity. Step number 2, instead of use the second number as the group quantity, we're going to use the second number as the number of groups. Step number 3, instead of removing one from each group until groups are empty, we're going to add one to each group until the groups are full. And step number 4, instead of the answer being the sum of the quantities removed from the groups, the answer is going to be the number of times that the quantities are added, or how many increments did we do. Problem solving method: 6 divided by 2 equals. Total quantity equals 6. Number of groups equals 2. Add 1 to each group until the groups are full. Increment number 1, we've added 1 to group 1 and 1 to group 2 for a total of 2. In increment 2, we've added 2 to group 1 and 2 to group 2 for a total of 4. Increment 3, we've now added 3 to group 1 and 3 to group 2 for a total of 6. The increment counter is 3. We've done this 3 times. 6 divided by 2 equals 3. Problem solving procedure method. Number 1, gather information. Number 2, create a new procedure. Number 3, perform the procedure. Number 4, test the procedure. Number 5, add new procedure to the body of knowledge. Test problem solving procedure. 5 divided by 2 equals. Total quantity equals 5. Number of groups equals 2. We're going to add 1 to each group until the groups are full. In increment 1, we add 1 to group 1 and 1 to group 2 for a total of 2. In increment 2, we've now added 2 to group 1 and 2 to group 2 and equals 4. What do we do with the final quantity? It does not equally distribute across the groups. Create problem-solving procedure for 5 divided by 2 equals. I'm going to implement a new creative strategy called extend. We're going to extend the adding of quantities to groups procedure. Steps 1 and 2 remain the same. Step 3 gets extended. We're not only going to add 1 to each group until the groups are full, we're going to add or last increment cannot distribute equally. And then to step 4, we're going to extend if last increment cannot distribute equally, then answer equals number of times quantities added minus 1 plus number left over divided by the number of groups. Else the answer remains the same as before, number of times quantities added. Test problem solving procedure. 5 divided by 2 equals. Total quantity equals 5. Number of groups equals 2. Add 1 to each group until the groups are full, or the last increment cannot distribute equally. In increment 1, we've added 1 to group 1 and 1 to group 2 for a total of 2. In increment 2, now 2 are in group 1 and 2 are in group 2 for a total of 4. What do we do with our last quantity? Well, our increment counter is at 3, but we have to apply our new step, 3 minus 1 plus the number left over, which is 1, over the number of groups, which is 2. 5 divided by 2 equals 2.5. Now we're going to retest our problem-solving procedure with new values of 7 divided by 3 equals. Total quantity equals 7. The number of groups equals 3. We're going to add 1 to each group until the groups are full, or the last increment cannot distribute equally. In increment 1, group 1 has 1, group 2 has 1, and group 3 has 1 for a total of 3 across the groups. In increment 2, group 1 now has 2, group 2 has 2, and group 3 has 2 for a total of 6. For increment 3, we have to apply our new rule. Our new step, or our new rule, is the counter 3 minus 1 plus the number left over, which is 1, divided by the number of groups, 3. The answer is 7 divided by 3 equals 2 1/3. Now we can teach a procedural problem-solving procedure. We can teach our students to gather information, determine if there's an existing answer. If there is, memorize the answer. If not, is there an existing procedure? If there is, perform the existing procedure. If not, create a new procedure. Perform that new procedure, test that new procedure. If it doesn't pass the test, go back up and fix the new procedure until it does pass the test. Then we can add that procedure to the existing body of knowledge to be used as an existing procedure. Teaching problem solving in K-12. Problem solving should be taught in a progressive spectrum across the grades. The lower grades should emphasize memorization, the middle grades should emphasize procedure, and the upper grades should emphasize problem solving proper. Problem solving should be explicitly taught, not simply implicit to the other subjects. It should be inclusively taught in all subjects and in all grades. It should be universally taught. It should be applicable to personal life as well as academic life.